IDEX Corporation is a Chicago-based fluidics company. We are a $2 billion company that provide engineered solutions to customers worldwide in niche market applications.
IDEX is a global fluidics leader serving high-growth specialized markets. We are best known for our expertise in highly engineered fluidic systems and components. Our products touch lives every day. Whether it's a life-saving rescue operation, dispensing fresh juice to a first grader, or fueling aircraft, IDEX is a leader in creating enabling technology. Headquartered in Lake Forest, Illinois, USA, IDEX was founded in 1987 and stands for Innovation, Diversity and Excellence. The company trades under the symbol IEX on the New York Stock Exchange and the Chicago Stock Exchange. IDEX Core Values. Our core values unite our teams around the world by setting the standards for behavior.
IDEX core values are the foundation of our operating model. They apply in everything we do.
Our customer is our priority. We grow our enterprise and people. Our integrity is paramount. We strive for excellence. We are passionate about success. IDEX has operating facilities across 6 continents with more than 6,800 dedicated employees worldwide.
IDEX has over 35 different businesses worldwide. These report under 12 different platforms, and these platforms are combined into 3 segments.
At IDEX, we design, manufacture and distribute some of the most recognized brands in the positive displacement, pump technology, fluid metering, specialty compressors and fluid handling systems.
This group is focused on 4 key market segments.
We address customer needs in the movement and measurement of process-critical fluids and gases in niche market segments. Our key segments include oil and gas, chemical, petrochemical, specialty chemicals, food, pharmaceutical, and water treatment.
Energy and fuels. Korken is recognized as one of the world's leading manufacturers of vane and turbine pumps and reciprocating compressors used in LPG and process industries. Farr-Herman designs and manufactures ultrasonic and turbine meters for custody transfer of liquids in upstream, refining and process industries. Sponsler Incorporated is a leading source for precision turbine flow meter systems which are used for measuring liquids and gases and also for cryogenic applications. TopTech Systems Incorporated provides a range of products and services to customers in terminal automation. Liquid controls. In the year 1954, Fred G. Wacker Jr., envisioning the idea for liquid controls, acquired the patent rights of George Richards' 3-rotor principle. After 2 years of research, development and testing, the first LC meter was sold to the United States Air Force. This M60 meter performed consistently for over 25 years. Over the years, liquid controls expanded manifold to serve its growing customers. In 1994, Liquid Controls Incorporated became certified to the International Standard Organization's ISO 9001 quality certification. In January 2001, Liquid Controls was acquired by IDEX and added to their pump group. Liquid Controls positive displacement meters cater to highly precise and accurate measurement of liquids in petroleum markets for custody transfer applications, including loading of white oils and black oils into tank trucks and tank wagons in terminals, unloading of fuels and lubricants from trucks at end-user facilities, blending of ethanol with motor spirit and biodiesel with diesel at loading racks, metering aviation fuel into commercial and military aircrafts when mounted on refuelers and dispensers, as well as helicopter refueling, measurement of diesel and fuel oil on trucks for facilities such as mines, cement plants, ports, construction sites, power plants and fleet management, and offloading and transfer of marine bunkering oil for ships and barges. Liquid control meters are also used for metering LPG on bobtails as well as for oil production, pipeline transfer of crude and refined products, bitumen loading into tankers, and lube oil loading and blending. The major markets for custody transfer are categorized as stationary, which includes bulk plant and loading terminals, aviation refueling, truck metering of refined fuels, batch processing of lubricants, and blending of ethanol and biodiesel with refined fuels.
In India, we started making investments way back in 1998.
We began in India from a couple of sales representative offices in 1998.
Year after year, we have made investments from a long-term perspective here in India.
We have grown significantly in India with our sales and customer support teams operating out of Delhi and Chennai other than Mumbai.
This is IDEX India facility in Savli, Vadodara. We set this facility in 2011. We recognize that our customers in India want the best products anywhere available in the world. And so we set up this world-class facility. Here we are currently manufacturing products for 6 different businesses.
Savli, Vadodara in India. The facility incorporates a highly effective team-oriented environment that integrates manufacturing, administration, and the industry's latest computerized technology. It also includes a state-of-the-art calibration and testing facility that meets custody transfer norms as per weights and measures.
The focus of the operations team is to delight the customers. What it means to us is that meeting and exceeding the customer's expectation on quality and delivery. The team of value stream managers as well as the functional leaders meets every day for around 15 to 20 minutes, and we discuss about all the matrices which we have defined to achieve these objectives. There are reports which are given by everybody on a daily basis on what is happening in each area, and we focus on working on the improvements which are required.
Liquid Controls PD meter. The Liquid Controls metering principle. A Liquid Controls positive displacement flow meter is, in a sense, a hydraulic motor with high volumetric efficiency that absorbs a small amount of energy from the flowing stream. This energy is used to overcome internal friction in driving the meter and its accessories. With all other conditions being constant, the LC meter does not vary more than 0.02% in repeatability over the entire range of the flow and has a very high accuracy of plus or minus 0.05%. There is no metal-to-metal contact within the metering element, and no contact means no wear. No wear means no increase in clearances. No increase in clearances means no increase in slippage. And no increase in slippage means no deterioration in accuracy. The LCPD meter is bidirectional and accuracy remains unchanged in either direction. The meter has a most ideal combination of minimum seal or slippage area with low pressure differential across this seal. This results in superior accuracy over a wide range of flow. The measuring chamber walls only sense the delta pressure across the meter inlet and outlet, which allows for thinner chamber walls with less distortion. System piping stresses that are absorbed in the external housing are not transmitted to the precision measuring element. Because of the LC meter's unique double case design, the bearing surfaces of the meter element are internally and externally subjected to the same system pressure. Due to the common coefficients of expansion of the critical parts of the LC meter element, the products can be measured accurately from -40 degrees Celsius to 71 degrees Celsius. Due to the minimum area in shear and the smooth flowing characteristics, the LCPD meter design gives an accurately metered product without calibration change. The rotors within the meter work like a pump and at a minimum head ensure that the product is transferred through the measuring mechanism into storage. The LC's unique strainer-cum-air eliminator design ensures a proper custody of measurement wherein the pockets of air at the final point of unloading from a compartment are vented and accurate measurement is ensured, determining pressure drop across the meter and the strainer. If the meter is to be operated at 100% of capacity, for example a 4-inch PD meter model MSAA 75, 100% meter capacity is 2650 liters per minute. The pressure drop for the Stoddard solvent at a flow rate of 2650 liters per minute would be 2.3 psi or 0.16 bar. Adjusting pressure drop to reflect viscosity. If the liquid to be metered has a viscosity of 7 centipoise, the conversion factor would be 1.2. The pressure loss would be calculated as pressure drop solvent multiplied by conversion factor equals pressure loss in psi. 2.3 psi multiplied by 1.2 equals 2.76 psi or 0.194 bar. Meter classes. Class 1 meters. Class 2 meters. Class 8 meters. Class 10 meters. Class 14 meters. Class 16 meters. MSAA 75P1, where M stands for meter. S represents the steel case design. And AA is the nomenclature for the pressure rating of 275 psi. 75 means a 4-inch size flow meter having a flow range up to 2650 liters per minute. P shows the accessory pulsar mounted on the meter. And 1 is the meter class indicating the material of construction of its internals. Liquid controls pulsar. Resolution 100 pulses per revolution per channel. Dual channel output offers redundancy. Explosion-proof housing, PESO approved. Pulse transmission distance 1524 meters. 90-degree phase shift between each channel. Pulse security feature for custody transfer. LC pulsar meets weights and measures requirements. It also meets the Security Level A of the API Manual of Petroleum Measurement Standards, Chapter 5.5, Fidelity and Security of Flow Measurement Pulsed Data Transmission Systems. Pulsar's unscaled pulse output is an uncalibrated or raw pulse. The electronic registration must have a scaler to further calibrate these raw pulses. The Liquid Controls PD meter and Liquid Controls pulsar are weights and measures approved. Liquid Controls basket type strainer. Strainers help to protect meters from serious damage caused by burrs dislodged from new piping, pipe scale or foreign material. They are always recommended at the inlet of the air eliminator in a metering system in line with custody transfer norms. They act as a low-cost protection for the meter housing. The LC strainer has a higher open basket area to pipe area ratio, resulting in lower pressure drop. 2-ply baskets are available in 20, 40, 80 and 100 mesh. Liquid Controls air eliminator. Eliminating the free air or vapor. The product is pumped through the system and enters the air eliminator. If free air or vapor is present, the pumping system moves the free air into the air eliminator. Once in the air eliminator, the air rises and vents from the center vent ports. As the product enters, it displaces the air, allowing the float to rise. As the float rises, the 2 reeds cover the vent ports. This stops the venting of air and prevents any product from leaking out through the vent ports. If free air enters the system, it will rise and displace the liquid. As the liquid level drops, so will the float. As the float drops, the 2 reeds are drawn away from the center vent port and free air vents from the system. This cycle is repeated anytime free air enters the metering system. Increases accuracy of the metering system. Installed at the downstream of the strainer and upstream of the meter in line with custody transfer norms. Effectively eliminates 88 cubic inches per minute or 2.49 liters per minute of air even with 1 port plugged. Available as a separate unit as well as combined with strainer. Liquid Controls Digital Control Valve DCV. The LC hydraulic control valve consists of valve with 2 solenoid controls, the normally open or NO and the normally closed or NC solenoid, located in the upstream and downstream portions of the control loop respectively. They control the operation of the valve. With both solenoids energized, high upstream pressure is blocked, allowing the product in the cover vent to lower the downstream pressure, thus opening the valve. Conversely, De-energizing both solenoids allows high upstream pressure to close the valve. Energizing the NO solenoid locks fluid in the valve cover, which locks the valve in a fixed position to maintain a constant flow rate. Whenever a change in flow rate takes place, the flow controller signals the appropriate solenoid to open momentarily to readjust the flow rate to its set value. A Y-type strainer is provided at the inlet side of the tubing to filter the solid dust and particles, preventing them from entering the diaphragm chamber. Needle valves are provided for fine-tuning the flow rate. The basic valve can be configured with an infinite number of control possibilities while still maintaining a simple, robust construction with simple servicing if ever required and few parts that may ever need to be replaced. Top-Tech Batch Controller. Yesterday, electronic presets and smart injectors. Today, Multi-Load 2. Multi-Load 2 RCU features. New electronics, 16-line color TFT LCD, Division 1 Zone 1 explosion proof, alphanumeric keypad, proximity card reader. The benefits of Multi-Load 2 are distributed scalable control, lowers installation, expansion and operating costs. Data collection is streamlined, one interface between TAS and hardware. Same hardware and firmware for all control devices, simplifies installation and maintenance and lowers cost of ownership. Flow Control Module 2. Flexible input and output for Multi-Load 2 package, mounted in an enclosure up to 4,000 feet away from the load rack. Typically one enclosure per bay. RCU2, part of Top-Tech's suite of access control and facility security products. Multi-Load 2, an innovative approach to load rack control, making traditional presets obsolete. BPA, scaled automation for bulk plants and small terminals, built on TMS-6 technology. TMS-6, the industry standard for terminal management system. Top Hat, multi-terminal management, host access for terminals. Top-Tech Data Services TDS, via the PetroNow platform. TDS offers data delivery and management tools, products from the entrance gate to the corporate back office. Liquid controls prover tanks. Types of proving tanks: fixed and mobile, top loading or bottom loading, pressurized or non-pressurized, online or offline, designed and manufactured as per IS 2341-1963 and Manual of Weights and Measures. Rugged and fully welded construction. Top and bottom precision level indicators. Internal baffle plate prevents vortex formation and related trapping of air. Provision to mount temperature gauge or RTD and temperature indicators. Mobile trolley is provided with screw jacks for leveling during filling and lockable wheel. Choice of accessories like motor, pump, starter, double block and bleed valves and SS braided hose can be provided on request. To ensure that the meters provide sustained accuracy and superior repeatability for custody transfer throughout its span of operation, these are the design considerations. By design, positive displacement flow meters have some clearances within the measuring chamber that permit some leakage or spillage of the product through the clearances. The amount of slippage is dependent on the clearances available, differential pressure across the clearance, and the viscosity of the products through the clearance. These meters need to be calibrated or corrected during calibration of the PD meter. Calibration conducted in the factory for the meters being built only confirms that the meters are capable of attaining the required accuracy and repeatability. An example of volumetric prover that once calibrated and sealed is considered a primary standard. A master meter proven against such a standard may then be used to calibrate other meters. Traceability back to the primary standard is accomplished by retaining both the master meter calibration test against the prover and the product meter under calibration. All the meters will be tested for linearity and repeatability on the IDEX fluid and metering test bench against master meters using Calibest L as a test medium at the ambient temperature and system pressure of 1 to 3 kilograms per square centimeter. The master meter is the reference meter which has been proved against the IDEX fluid and metering 5 KL prover tank. The master meter providing data will contain the master meter K factor at different flow rates. The meter under test will be installed on the IDEX fluid and metering test bench against the master meter. Feed the K factors of the master in the batch controller for the master meter. A flow rate of 1500 LPM will be set using the master meter with batch controller. At 1500 LPM, 3 readings of the test meters against the master meter are recorded. The master meter and meters under test will indicate the readings in liters and pulses respectively. K factor at 1500 LPM will be calculated from the master meter readings in liters and the test meter readings in pulses. Repeat the same steps for flow rates of 1200, 800, 500 and 250 LPM. Feed the test meter and the master meter K factor data into the respective batch controller. Set the flow rate of 1500 LPM as required and the batch value in liters in the batch controller. Take 3 test runs and record the readings of the master meter and the test meter at the end of each batch. Repeat the same steps for the other 4 flow rates 1200, 800, 500 and 250 LPM. Calculate the percentage error of the system and the linearity of the meter for the percentage error reading as per the formula. Calculate the repeatability and the linearity of the meter for the percentage error calculated. General procedure for calibrating the master meter against fixed prover. Mount the master meter in series with the prover in the pipeline carrying the liquid into the proving tank. The proving tank is filled once or twice to wet the surfaces and to remove the entrapped air. Check the temperatures and pressure. Ensure that these are stabilized during calibration tuning. Pass a quantity of liquid at a specific flow rate equivalent to the capacity of the prover. Record the temperature at the flow meter and the average temperature of the prover along with pressure. All the master meters will be calibrated against the LC prover using Calib Test L as a test medium. The LC prover tank is of 5 KL capacity and has been stamped and sealed by Weights and Measures Gujarat, the statutory authority. The master meter with LC pulse output device model POD and the electronic counter with indications of rate of flow and total will be installed along with the LC master meter on the IDEX fluid and metering test bench. A flow rate of 1500 LPM will be set using the master meter and the prover will be filled completely to wet for 10 minutes. The prover will be drained and set to 0 at the prover's bottom gauge glass. At 1500 LPM, fill the prover. At the end of the run, the prover reading and the meter pulses reading will be recorded. Repeat steps for another 2 runs. Repeat steps for the flow rates of 1200, 800, 500 and 250 LPM. Calculate the K factors from the prover and the meter readings for all the flow rates. Feed the master meter K factor data into the batch controller. Set the flow rate of 1500 LPM as required. And the batch value of 5000 liters in the batch controller. Take 3 test runs and record the readings of the prover and the master meter at the end of each batch. Follow the same steps for the other 4 flow rates 1200, 800, 500 and 250 LPM. Apply volume correction, temperature correction and pressure correction as per API Chapter 4. The final corrected volume is to be compared with the flow meter reading. Calculate the K factor at a specific flow rate or the meter correction factor. Compute the K factors, repeatability and linearity. The filling of the system must take place slowly to avoid spikes or transients caused by rapid acceleration or deceleration of the product. The system is to be designed to make sure that a positive head condition will always prevail in the system. Prevention of air entering the system and prevention of vapor generation within the system is a key factor in ensuring the accuracy and repeatability of the measurements. Care must be taken in the installation to not create zones where the product can be locked between two closed valves. If lighter petroleum products are trapped between two valves, and if the temperature increases by 1 degree Celsius, the resulting pressure change will be in excess of 8.8 kilograms per square centimeter. A thermal relief valve needs to be provided in such installations, and the proper path of the thermal relief would be typically towards the upstream valve. Installation, commissioning and maintenance. PD meter installation. The entire piping system should be thoroughly flushed of all debris prior to meter installation with a liquid compatible with the meter construction. The meter installation position should allow for easy access towards any routine service and preventive maintenance. The meter must never hang on the connecting piping. It must always be securely bolted to a platform. Mounting the same on a skid would allow ease of installation. Do not create pipe stress or strain when piping the meter. The metering system should be designed to keep the meter full of liquid at all times. A thermal relief valve must be installed either on a strainer or on the air eliminator to ensure safety against thermal expansion. Variations by repositioning the flanged spool. While flanged spools are normally positioned in line for straight-through flow, many other positions are available to meet a particular installation requirement. Some of these other possible configurations are shown here. The meters operate with equal accuracy in any of the positions indicated. PD meter commissioning. When taking the meter into operation, the system should be filled slowly with liquid to ensure that the meter does not rotate air or vapor at speeds higher than what it is rated for. Slow filling can be ensured by throttling the meter isolation valve. PD meter maintenance. A liquid-controlled PD meter requires little or no maintenance if properly installed and calibrated as per recommended practices for refined fuels. In the event of any corrosion in the piping and subsequent accumulation of foreign particulate matter, it is recommended at such instances only to open and clean the measuring chamber. Strainer installation and commissioning. The entire piping system should be thoroughly flushed of all debris prior to installing the strainer. The system should be designed to keep the strainer full of liquid at all times. Protective caps placed in the openings of the strainer before shipment should remain in place until you are ready to connect the piping. The strainer installation position should allow easy access for service. Provide an isolation valve at the inlet of the strainer for servicing and cleaning of the basket. Never hang a strainer on the connecting piping. When piping the strainer, do not create pipe stress or strain in order to complete the installation. The direction of installation with respect to the flow, left to right or right to left, should be maintained for the FS series. Look for the arrow marking for proper flow direction. Strainer maintenance. Check the strainer daily during the first 100 hours of operation or until no more debris is found in the strainer. Thereafter, the strainer should be checked once every 3 months. The frequency may vary based on any specific service conditions, throughput and product cleanliness. Air eliminator installation. Look for the arrow marking for proper flow direction. The vent of the air eliminator should be at atmospheric pressure. The vent is provided with a ball valve. The ball valve is to be kept in the open condition all the time, except in the event of any leakage. Air eliminator commissioning. Close the manual valves located at the outlet and inlet of the air eliminator. Start the pump. Open the inlet valve slowly and allow the air to bleed through the vent. Once air stops coming from the vent, open the outlet valve. If care is not taken, a sudden rush of liquid may cause damage to the float. During initial operation, due to the mixture of air and liquid, some product will come out from the vent. This is not leakage. Air eliminator maintenance. Foreign particles may get deposited on the valve plate near the vent due to atmospheric dust or with the product. This may cause leakage through the vent. The valve plate can be accessed as per the pictures shown here and would need to be cleaned. DCV installation. The valve can be mounted horizontally or vertically. Space must be available for providing maintenance. Flush the pipeline. Ensure that the flushing is done with liquid compatible to the valve. Check the flow arrow on the valve body. All valves for petroleum services must be installed over the seat flow. This will help the valve to close in the event of any fail-safe condition. The valve should be adequately supported on the piping. It is recommended to install a manual valve upstream or downstream for easy draining of liquid during maintenance. DCV commissioning. Start the pump. The valve should remain fully closed. Bubble-tight shutoff is required. Energize NO solenoid. No flow. Energize NC momentarily and de-energize very quickly to lock the liquid in the cover. Observe low flow. This two-stage opening can also be made to operate in multi-stage. By repeating the steps, keep on energizing and de-energizing NO to maintain high flow at set level through batch controller. De-energize NC. Flow starts reducing. Flow rate can be further reduced by de-energizing NO momentarily and energizing it again immediately. De-energize NO. Valve fully closed. DCV maintenance. Check the strainer, solenoids and diaphragm after initial setup for any accumulation of debris movement and clean as appropriate. Needle valve needs to be locked after tuning or speed setting. Troubleshooting PD meter. Product flows through the meter but does not record correctly. Possible cause: the meter is not properly calibrated. Solution: recalibrate. Air in the system. Solution: ensure air eliminator is installed upstream of meter and venting entrapped air through its ports. No flow through the meter. Possible cause: faulty pump. Solution: check the pump and repair or replace as required. Valve not open. Solution: check valve internals and check the functionality of the valve solenoids and clean if required. Foreign particles inside the measuring chamber. Solution: clean the meter. Troubleshooting strainer. Meter runs too slowly. Possible cause: the strainer basket is clogged. Solution: open the strainer and clean the basket. Meter locks up. Rotors do not turn. Possible cause: foreign particle entering the measuring chamber due to strainer basket rupture. Solution: replace the strainer basket and flush the metering system with a solvent compatible with the meter and the strainer internals. High pressure drop across the strainer or loss of flow rate. Possible cause: the strainer basket is partially clogged by foreign particles or dried material. Solution: clean or replace the strainer basket. In case the problem persists despite regular maintenance and cleaning. Solution: inner mesh may not be correctly sized for the product. Therefore, replace with a mesh appropriate for the product viscosity. Leakage at the strainer basket cover. Possible cause: O-ring or seals damaged due to ingress of dirt. Solution: replace the damaged O-ring or seals and clean the housing. Troubleshooting air eliminator. Leakage through the air eliminator vent. Possible cause: foreign particles deposited on the reed and valve plate near the vent due to atmospheric dust or with product. Solution: open the assembly, inspect and clean the surface of dirt and reassemble. Reed and float alignment disturbed. Movement of reed and float assembly stuck due to alignment issue of the center rod. Solution: open the assembly, inspect the alignment and set it right. The float is ruptured. Solution: Replace the float and ensure that the metering system remains full of liquid. Check whether the pump NRV is passing and ensure proper setting. Leakage of the product through the air eliminator vent happens on days when there is no loading. Solution: ensure that the thermal relief valve is installed on the air eliminator flanged elbow to account for thermal expansion of the product. Troubleshooting: DCV. DCV not starting. Possible cause: valve solenoids not responding. Solution: check solenoid functionality. Replace the coil and solenoid if functionality is not appropriate. Solenoid internals upon inspection show foreign particles. Solution: clean the internals and clean the strainer basket. Debris accumulated on the diaphragm surface. Solution: check the diaphragm and clean the surface of the diaphragm and the internal parts of the valve. Diaphragm ruptured. Possible cause: diaphragm rupture may be due to transient pressure or foreign particles. Solution: replace the diaphragm. Flush the line with a liquid compatible with the metering system. Ensure that the system is filled with liquid. Clean the valve strainer basket. DCV not getting cut off upon completion of the batch. Product leaking slowly after completion of preset. Possible cause: valve solenoids not responding. Solution: check solenoid functionality. Replace the coil and solenoid if functionality is not appropriate. Insufficient pump pressure. Solution: check the pump pressure and any partially closed valves in the header line. Ensure that the header valves are open. Check the metering system strainer basket for any clogging. Clean the basket if the metering system strainer is clogged. Flow rate hunting and excessive vibration during loading. Possible cause: needle valve not properly tuned. Solution: tune the needle valve appropriately. Limit switch not responding. Possible cause: stem assembly jammed. Solution: disassemble and check free movement of the assembly. Replace if required.
We have products with proven design and they have been working for a number of years. What we focus on is manufacturing the quality in the product rather than doing the inspection.
We are investing heavily into infrastructure, people, process and systems. More importantly is the investment we are making in people. We are investing in developing our team here. We are growing our people. Engaged and professional team is going to deliver excellence to our customer.
Everyone associated with liquid controls is committed to pursue perfection. We accurately define and fulfill customers' continuing and changing needs. We strive to minimize the user's total cost by providing products of high reliability and zero maintenance. Our goal is to be simply the best.